Hello all, welcome to another session with me, Varun at Ekagra. And in this session, we'll be talking about the next chapter that is of class 8. And in this video, we will be discussing about the chapter 4 that is materials which talk about metals and non-metals in specific. Now, these videos are being made to reach out to a few out there who are really looking for some good videos on YouTube, or probably because of your school not being able to teach you proper English. So if you have any of these reasons, I think these videos are perfectly for you, right? So I really hope that I'm able to help at least a few people out there, or a few candidates who are genuinely looking out for something. And these videos are an attempt to reach out to people like, or students exactly like you. So if you have any queries, or if you have anything that you would want to discuss about, then please reach out to me on this Instagram platform that is Hyderabadi underscore Chora, or you may want to leave a message on the comment section below on the YouTube platform that you're looking at. So without wasting time, let us go further and talk about the actual chapter that is materials, which talk about metals and non-metals. And this is your chapter 4. Now, when we talk about metal or non-metal, we've already seen what non-metals are. Anything which is not a metal is a non-metal. And we've seen, some variants in the even in the previous class, even when you talk about rayon, or it could be nylon, or it could be paper, or it could be cotton, or it could be any of these materials can be classified as non-metals too. But then let us properly understand the difference between them. Now, when we talk about a metal, we see that it has certain qualities. And what are these qualities? We know that metals are strong, and if you get hit with a metal, then you'll definitely have a lot of pain, right? Now, when we talk about non-metals, is the case the same? Well, this is where we may want to, probably hold for a second and think before you answer. Because when you talk about a small piece of coal, or probably anything as such, they can be broken down into small pieces. But can a metal be done that way? No, it can't. Right? Now, this is like one of the most ground difference between a metal and a non-metal. Now, having said this, you saw how that shape of nail, the nail that we've seen in this image here, we all know how this small piece of nail is being given a shape. And this nail that we look at, even if you beat it very hard, it'll only keep going straight, and it would not change its shape. But when we talk about a sheet of of any metal, then you see how the shape of the sheet can be changed. Even the silver foil that you use to to put it on these sweets, to decorate sweets, or probably you must have taken sandwiches or roti or chapatis to your school, and when you do that, you must have had food wrapped in this aluminum foil. Now, this property of metals, where they can be broken down into, or they can be cut into thin sheets, is called as malleability, right? And it's very important to understand if a metal is malleable or not, based on which you would want to use a metal for certain properties or for certain works to be done. Now, going forward, if you talk about a metallic pan, okay, let's just understand why it's important, or some other properties of metals. Now, when you talk about a metallic pan, or probably anything which is metal, would you be able to hold it on a stove even when you don't have a plastic handle or a wooden handle at the end? Well, I don't think we'll be able to do it, because they are real good conductors of heat and electricity. Now, having known this, it is for us to understand that metals can be broken down into, or can be cut, or can be shaped into different elements based on your usage. For example, the property of metal, uh, when you cut it into sheets, if that is called malleability, okay, let us also write down what it is. If you can cut it down into sheets, if this is called malleability, then the way you can cut it into wires. Oops, there's no T here. Yeah. If it can be cut into wires, then it's called ductility. Ductile. You would want to know if a metal is ductile or not. We all must have seen a lot of copper wires, right? When you probably check what is inside a wire, an electrical wire, you would see that the metal or the element used is copper. But have you ever seen that we use stainless steel wires, or probably have you ever come across silver wires? No, it's only generally copper that we use in most of the cases, or aluminum. Now, why is it that way? It's because these elements or these metals are ductile in nature. Also, the third property that metal has is they are sonorous. Now, what do you mean by sonorous? Sonorous generally means that they can probably come out with a good sound. When you drop a metal plate, or probably when you hit on your almara, you notice that it produces a kind of reverberational sound. Now this is what we call as sonorous. It is that sound that gets produced. Now at the same time, if you drop a plastic or probably a non-metal, would it produce equal kind of sound is something that I would doubt. And there are also some more properties, like metal is a real good conductor of heat and electricity. Both of them, metal can really handle them pretty well. And if you don't handle the metal properly, then there is a very high chance that you may get that electric shock. So, which is predominantly one of the reasons why you want to handle it properly. But then when you take a look at non-metals, you would see that elements like sulfur or carbon or oxygen, you wouldn't be able to cut them with a knife, or you wouldn't be able to kind of handle them like how we handle metals. Now we have metals like sodium and potassium, which can be very easily cut with a knife, as easy as a cake. And mercury, these are some special points that you may want to know. Very frequently asked in exams. So let me just write things down here. You have metals like sodium and potassium, which can be cut easily, and they can be cut using a knife as well. Then you have the seventh one, or the seventh point, which is mercury. I think mercury is written as Hg, and mercury is the only metal in liquid form. This is another exception that you might want to know about metals, right? So please do not forget them. You could be asked these questions directly when you go to your exam hall. Now, when you talk about metals, you see that on a lot of metals, rust is formed. Now, what is rust? Rust is generally formed because of prolonged action of oxygen and water on that. Now, you don't have to actually pour water on that metallic piece, but there is water in air, moisture that reacts with this metallic object to form rust over time. Now, there is a small test that we have here. There's a small activity, and this is something that your teacher is supposed to do. Please do not perform this at home or school all by yourself. Now, if you want to check the nature of rust, then what you can do is you can take some very little amount or quantity of water. You can add some rust into it, shake the solution or shake this suspension very well, and then you can test the solution with the red and blue litmus paper, and you would notice if it is acidic or non-acidic in nature. And these kind of tests are done so that we understand how every metal can be handled. Now, the moment you add, this sulfur into the glass jar, the jar that you have when you already added it, you would want to burn it, and you would want to close the lid so that it doesn't escape. And you would again want to shake the tumbler well, and you would notice now that the color of the litmus paper is changed. Things like these would also tell you if it is acidic or basic in nature. Now, this comes as a query to a lot of candidates as to why do we have to use a litmus paper? Like, what does litmus paper indicate? Like what happens if it goes from red to blue or blue to red? Well, it is to check if it is basic or acidic in nature. Right now, going forward, let's talk about some chemical properties of metals and non-metals. Now, here, when you look at it, you have reaction with oxygen, which is uh, the first thing to be discussed. Now, when you uh, look at it, there are different ways to understand it. An iron object may get rusted, but have you ever noticed a copper getting rusted? A copper generally does not get rusted, but it turns green because of this kind of deposition. Now, again, there is a certain test for you to understand if this is again acidic or basic in nature, and you can read about it in your activity, and I'm pretty sure your teacher would be able to assist you much better on this. But just to understand things on a very layman level, this the product formed. Now which product are we talking about? We're talking about a small strip that is being considered, the oxide of magnesium, probably, which is basic in nature. But even before this, what did we actually do? We are actually burning down a magnesium ribbon, and this ash that we have obtained, we're trying to dissolve it in water and then check if it is acidic or basic in nature. And likewise, now we are trying to observe how different non-metals react with oxygen. And in this, the first is that we would want to talk about is sulfur dioxide. Now, whenever we talk about a metal or a material or a non-metal like sulfur dioxide, when you mix it with water, it becomes sulfurous acid, which means in this case, your litmus is turning into red from blue. And if it is going red, then it is acidic. As simple as that. And this is how you may also want to remember it. Now, this sulfurous acid that is available, it turns the blue litmus paper red. And generally, oxides of non-metals are acidic in nature. Now, this is one shortcut for your exam or for your overall preparation that you may want to remember. Anything which is an oxide of non-metal, they are generally acidic in nature. Now, going forward, let's also understand the reaction with with water. Now, when you talk about a reaction of sodium with water, it's important to know that sodium gives a very violent reaction when it's with water. While some other metals they don't do the same. While iron reacts very, very slowly, iron takes its own sweet time to come up with any reaction with water. And generally, again, we're talking on a very general footnote, we see that non-metals, they don't react with water by much, but they may be very reactive with air. For example, there are a lot of non-metals which are stored in water, or which are stored in huge containers with water. And phosphorus is one such example, because phosphorus as a non-metal is very, very reactive. Even if it is exposed to air, it immediately catches fire and nothing else, nothing less than that. So, to prevent the contact of phosphorus with atmospheric oxygen, it is generally stored in water. We're talking about phosphorus as of now. Likewise, there are other elements. Right. Now, here, there's a question that is being asked, and that question is there any difference in a way or between how metals and non-metals react with acids? Well, there's a huge difference, trust me. Now, what could this pop sound mean when you bring an element close to the test tube? Whenever you have this pop kind of a sound that comes in while you're trying to burn a matchstick near the test tube, or in any of these cases, it generally means that there is presence of a metal, of an element. And what is that element? That element is none other than hydrogen gas. If you can see here, you have an answer also that's written. This pop sound that you get when you light fire close to the mouthpiece of a test tube, it's because of the presence of hydrogen gas. And metals react with sodium hydroxide to produce hydrogen gas. So hydrogen gas is a byproduct that we get because of this kind of a reaction. And reactions of non-metals with bases are pretty complex, and we don't want to talk about it right now. That's pretty much of chemistry, and we'll probably talk about it as we have to talk about equations. But let's enjoy the subject as of now. Here you have various experiments that are handled or that can be seen, and you can see that A and B, these two jars are changing in their colors and in their state also, probably by a bit. But C, D, E are completely non-reactive. Why? Because in beaker A and beaker B we have copper sulfate, while in others you have zinc sulfate, iron sulfate, and some more zinc sulfate, right? So here what do we understand? We understand how one metal or one material is overtaking another. For example, you have read that one metal displaces another metal in its compound in aqueous solution, right? So here we are trying to understand how and what happens to them. So in beaker A, that is the first beaker where we saw that the color has changed. I hope you've also kept your textbooks open. Guys, please keep your textbooks open so that you can match with whatever I'm talking, and it becomes easier for you to keep a mark of it. So in this beaker A, wherein you have zinc, it is replacing copper from copper sulfate. And that is why this blue color of copper sulfate is disappearing and a powdery red mass of copper is getting deposited at the bottom of the beaker. While you can see from this image how the last three beakers don't change their color because they are non-reactive kind of elements, and I mean they don't react much with the kind of element that you have had, and they neither are these replacive kind of elements. Now what do you mean by that? You have something called as replaceable elements, and this happens when one element is stronger than another. We look at it as in as we keep going ahead, but as of now this is a very important takeaway for you right now. So here you have also a small exercise, and you may want to do some research on this and post it in the comment section below too. That is, can you guess the sequence of metals from more reactive to less reactive amongst zinc, iron, and copper? And how would you be able to do that is something I won't tell you. You would give me an answer, and you would also tell me how did you come to this answer. Right? Now, the next is uses of metals and non-metals. We'll talk about the next very important topic. Now, we all know the difference between metal and non-metal, so we don't have to talk about the ground differences, but let's just understand things at a superficial level. Now, non-metal is essential for our life. It brings all living beings, the capacity to inhale when you're breathing. Non-metals are used in fertilizers to enhance the growth of plants. They're used in water purification processes. They're used in crackers. They're used in these purple colored solutions, which is applied on wounds and antiseptic, typically on a tincture lotion or on a tincture liquid that you see. You have huge presence of non-metals. Now, another small exercise for you is please write down some uses of non-metals that you come across in your daily life, and you may want to talk about that to me on my Instagram channel with the name that you can see below, or probably you may want to get back to me on the comment section on the YouTube channels below. Notwithstanding all of these, there is one last material or kind of metal that we need to discuss about, and that is called a metalloid. Now, what do we understand from now? All these qualities are about metals, this entire section. But when we talk about metalloids, what are they? Metalloids are basically those kind of elements which have properties of metals and non-metals too. Right? They possess the characteristics of both. All right, please remember this. It's a very, very important for you to remember. For you to remember this. Notwithstanding metalloids, you have something called as element two. Now, what do you understand by element? Element is uh, okay. If a substance cannot be broken down by any chemical reaction, okay, if you know that the substance has reached its final part, it could be by heating, cooling, or by electrolysis. There's nothing else that you can do about it. That is when it's called an element. And some examples that you have are sulfur. Sulfur is an element. Even iron. Iron is written as Fe. Right? Even iron is an element. Carbon is an element too. And the smallest unit of an element is atom. There's nothing that you can do about them much. They can probably react with another, but they cannot be broken down into any further component. Now, that is what we mean by element. So I hope by now you have understood what are the different topics and subtopics we have associated in this chapter. Of which the first one that we saw that we discussed, oops, is atom, conductor, displacement reaction. Displacement reaction is wherein one metal which is heavy and powerful replaces another. Again, this does not happen if the metal is less reactive. Only the metal which is more reactive displaces the one which is less reactive. You have ductility. Ductility is the capacity to break down into wires. Then you have element. Element is like the smallest breakable compound. Hardness is how strong it is. Malleability is the capacity to be broken down into sheets. Metals are those are the ones which possess these qualities on the left. Metalloid is a combination or it has shared properties of metals and non-metals. We all know what non-metals are, and sonorous is a property of metal wherein it produces a lot of sound in order to understand, or the ringing effect or the ringing kind of reverberation that we have is something what a non-metal has. Is something that a sonorous property has, and this is seen in metals. I'm sorry, that's my bad. Now, I hope by now you can answer almost all of these questions, and you should be able to answer them with confidence. And as I said, if you have any query or there's anything that you would want to talk to me about, you have the Instagram ID which is mentioned right below, or you can reach out to me using the comment sections that you have, right? And if you have any more queries, then now you all know what to do. Thank you very much for being with me. It was really nice and a lovely experience for me to to probably talk about science of chapter 4. In the next video, I would want to enrich this experience of interacting with you by probably coming back to you with chapter 5, which talks about another topic on the whole. Stay tuned. We are about to come up with almost all subjects from 8th class to 10th class, and then we'll also start with subjects which are from 6th and 7th as well. Till then, stay tuned, stay subscribed, and keep maintaining your social distance. Stay healthy and stay hydrated. This is me, Varun, your trainer and your mentor, signing off. Wishing you an all the best and great luck if in case you're probably taking up an exam, or if in case you're about to start preparing for any of these. Have a great day ahead and a blast of a time. Thank you very much.